Hello, beautiful people. How are you today? I hope everybody's doing pretty good. Um, and welcome to the show. This is a show where we read scientific literature and try to take some of that information and translate that to real world applications. Okay, and we specifically focus on animals because I love animals and I find them very interesting. They do very interesting things, okay? And today we're going to be reviewing this paper. It's called Mimicking Dolphins to Produce Ring Bubbles in Water, okay? So what is the motivation for this study? Really, we have seen that dolphins have this remarkable ability to form rings in the water, right? And so we didn't know if this was a random process or not. So what happens is that it turns out to be that mothers watch and show proper ring formation to the juveniles. Juveniles are just younger dolphins. So younger dolphins have to learn how to make proper rings. Okay. And what does this tells us? Actually, I had this curiosity thing where I still don't know, and people still don't know why they do it. People think that when they are curious and playful, they just form these rings just to play. But we really don't know or understand the real reason for them forming these rings. Okay, and they also care about the quality of the ring. Okay, and also we found by this experiment that it requires cognitive capabilities, and also we need control and shape and time control of shape and timing. So there's just no random way to do it. They have to contract muscles in a certain time. We're talking about microseconds, which is a very small amount. Not even a second is micro. So think about 0.00, it would be five zeros, and then one would be a second. Okay. Um, and let's keep moving. Okay. So this work really wants to understand how they do it by doing it in an artificial way. Okay. So now we look at the dolphin, how they do it. Something that I want to say right now is that we still don't understand also how or where the air is coming from, where's the pressure coming from. We just know that the air gets stored in the lungs and then from the lungs gets out through the blowhole. A blowhole is a small opening where they form, where they breathe through the blowhole, and also they expel air to form the bubbles through this blowhole. Okay, and this is the artificial setup of the experiment. They have an air pump right here, and they have a water tank, which would be this one right here, and they have also a small opening that would be mimicking the blowhole. Okay, so it would be right here. As you can see, they took timing to see how long did it take to make the nice ring. The duration to make a really nice ring, it would be around 0.030 seconds. So it's not right here. It should be like right here. But as you can see, it doesn't even take half a second to form that nice ring. Okay, so it's really really fast. Now, as you can see, we can see right here that they also took some measurements and at time zero, microseconds, 163 microseconds, but yeah, they just they were just taking images along the way. Okay. Something very interesting is that they use a high-speed camera at 109.50 frames per second. So it's a slow motion camera. We can say that. So it takes about 950 pictures per second. Okay, that's my understanding. For all of you camera fans, if you want to correct me, you can put a comment down below. Okay, and also uh, they use this device called a velocimetry device, particle image velocimetry device, PID, to show the amazing combination of air and water inside the just of air and water, the waves that they form to make the ring. Okay. As you can see right here, it was quite complex. And it also, I really don't know how that works, but that's what they used, okay? Now we can see right here, this is, don't focus on this yet. I'll explain it in a little bit, focus on part A. So to assess the quality of a ring, they said A is successful, this is successful, this would be a partial ring, and this would be a poor ring. And because I don't know how to play this again, I'm gonna go back and come here. So this is the way the ring forms, right? Starts from the bottom and then it just makes an amazing ring. Check it out again. Wow, it's just amazing, right? Amazing how it doesn't just disappear in the water. It just, I think it also has to do with pressure, the amount of pressure that the air is out uh, to keep that ring uh, proportional, okay? And this would be a successful ring right here. This would be a poor. Let's watch it again. Okay, this would be a successful ring, a poor ring, successful, poor. You see, poor, it starts to fade away. Successful, it just keeps in shape and it starts to get better. Okay, so now what's the discussion of this? The discussion of the paper is that ring formation really depends on pressure inside the lungs and muscular opening because the experiment shows that. So the more pressure they put, the pressure would be the vessel, the more pressure inside the vessel, and also the opening of the hole. Um, in this case would be the valve opening. So the more pressure, and they had to be adjusting the valve opening to make a nice ring. So that if that doesn't happen, then a ring is not nicely formed. So that tells us that dolphins have to be really aware of the time that they're contracting. They're contracting for the muscles. They have to be aware of the time, and also they have to be aware of how much pressure they need to put in order to form a nice ring, and whatever size they want, or whatever yeah, just whatever size they want. Okay, and also to make a really nice ring. So ring formation is not random. That's the thing. And some of the fun part of this experiment, are some real world applications. That's what we really care about. We can have some gas liquid transfer. I was thinking about we can just transfer gases through liquid. I still don't know why we would use this for, but if you have an idea, just put it in the comments. I'm going ahead and read them all, and just check them out. It's also good food for thought. Also, removal of dangerous gases in industry. Maybe they have very dangerous gases that they really don't want to touch, or they don't want to store, or maybe they don't want to transport those gases because they could be very toxic and kill people if they were to go out. Maybe we can, no, I don't know, sulfuric gas. I really don't know. But it could be a very dangerous gas. And we can just maybe remove it through water and then just send it to somewhere safe. Maybe a tank that is safe, right? Also, carbon dioxide sequestration. We can probably bring air from the just the way dolphins do it, air from the atmosphere, and bring it down, and then convert it into something else. So that could be also something good. We can just do it in the water because water, the air would not get dissolved in the water. But these are just some ideas. But if you, like I said, if you have more ideas, you can free feel to comment. And I really love you guys and have a wonderful day. Okay. Thank you. And I'll see you in the next paper. Okay.